It's June 3rd, 1997. Lyon, France.
More than 40,000 football fans have gathered inside the stadium for what seems like an ordinary international friendly.
Brazil against France. Nobody in the crowd knows it. Nobody watching on television knows it. And not even the players realize they're about to witness one of the most extraordinary moments in football history. Brazil are awarded a free kick. The ball is almost 35 meters from goal. The angle is poor. The distance is enormous. Most players would simply cross the ball into the penalty area. But one player has a completely different idea. His name? Roberto Carlos. For the next few seconds, time itself will seem to slow down. And what happens next will be replayed, analyzed, and admired for decades. Not only by football fans, but by physicists, engineers, and scientists around the world. Because one simple kick would make millions of people ask the same question. How did that football do that? For a brief moment,
everything becomes still. The referee checks the defensive wall. The goalkeeper carefully adjusts his position. 4 defenders stand shoulder to shoulder, confident, focused, ready. Roberto Carlos slowly walks backwards. 1 step, 2 steps, 3. His eyes never leave the football. The stadium falls silent. 40,000 people, waiting, watching, wondering. Then, the whistle. Carlos explodes into his run. 1 powerful step, then another. His left foot swings through the air with astonishing speed. For the briefest fraction of a second, the football changes shape. It compresses beneath the force of the strike. Then, it springs back to life. The ball rockets away, faster than 100 kilometers per hour, straight toward the outside of the defensive wall. The goalkeeper watches calmly. The defenders don't move. From where they're standing, the shot looks terrible. It's heading nowhere near the goal, or so everyone believes.
from the goalkeeper's point of view, everything looks perfectly normal. The shot is heading safely wide, outside the wall, wide of the post. Safe. Or so it seems. The goalkeeper doesn't move. The defenders don't move. Even the crowd begins to lose hope. Then, something changes. At first, it's almost impossible to notice. The football begins to drift. Just a little. Then, a little more. The curve becomes stronger and stronger. The goalkeeper suddenly realizes the ball isn't going wide. It's coming back. He launches himself across the goal, stretching every muscle, reaching with everything he has. But the football keeps turning, closer and closer and closer. Then, it curls perfectly inside the goal. For a brief moment, the entire stadium falls silent. No one can quite believe what they've just seen. Then, 40,000 voices erupt at once. Around the world, millions of football fans will watch this goal. Again, again, and again. Not because it was the most powerful free kick ever taken, but because it seemed to do the impossible. How could a football change its direction after it had already left the player's foot? That question would puzzle football fans and fascinate scientists for decades. Every football fan knows that spinning the ball can make it curve. Players have been doing it for generations. Roberto Carlos, David Beckham, Lionel Messi, Juninho Pernambucano. They all share one invisible teammate, the air itself. But here's the real mystery. Air is everywhere. Every player kicks through exactly the same air. So why can only a handful of players make the football bend with such astonishing precision? How do they persuade something completely invisible to guide the ball exactly where they want it to go? That is the real secret. Because the air isn't moving the football by itself. The player is controlling the air without touching it, without seeing it, using nothing more than the way the ball is struck. And that changes everything. So, how do the world's greatest free kick specialists persuade a football to follow such an extraordinary path? One question still remains. What about the wind? Surely the wind must be responsible. Yes, the wind does have an effect, but not nearly as much as most people imagine. A football reaches the goal in little more than a second. The journey is so short that even the wind has only a limited opportunity to change its course. It's rather like a bullet fired from a gun. Gravity is always pulling the bullet downward. But because its flight lasts only a very short time, the drop is relatively small over short distances. A football behaves in a similar way. The wind is present. It matters. But during such a short flight, it isn't the primary reason the ball bends so dramatically. The real secret begins much earlier. At the exact moment the player's boot meets the ball. Most people imagine that every powerful shot is struck directly through the center of the football. But the greatest free kick specialists almost never do that. Instead, they deliberately strike the ball just a few centimeters away from its center. That tiny difference changes everything. The football still races towards the goal, but now it begins to spin faster and faster and faster. And with every rotation, the football begins to reshape the air around it. And that changes everything. The ball is now spinning rapidly, but something even more remarkable is happening. The ball isn't simply moving through the air, it's changing the air around it. Now imagine that you could actually see the air. Millions of tiny air particles flowing around the spinning ball. On one side, the surface of the ball is moving in the same direction as the airflow. It gently pulls the air along. The air speeds up. On the opposite side, the surface is moving against the airflow. The air slows down. Now, the air is no longer balanced. One side has faster moving air. The other has slower moving air. Nature doesn't like imbalance. It always tries to restore it. Where the air moves faster, the pressure becomes lower. Where the air moves slower, the pressure becomes higher. That difference in pressure creates something invisible, a gentle sideways force. Not just once, not just at the beginning, but during the ball's entire flight, every fraction of a second. The air pushes the ball, ever so slightly, to one side. Again, and again, and again. That's why the curve becomes greater, the longer the ball stays in the air. The ball isn't changing direction by itself. The air is guiding it. Physicists gave this remarkable phenomenon a name, the Magnus effect. And for more than a century, it has explained some of the most spectacular free kicks ever seen on a football field. Understanding the science is only part of the story. Using it is something entirely different. Every professional footballer strikes a ball, but only a handful can make it dance through the air with astonishing precision. That takes years of practice. Thousands upon thousands of free kicks, each one teaching the player something new. How much spin is enough? How much power is too much? How the distance changes the curve. How the position of the wall changes the target. And how even the slightest change in the point of contact can completely transform the ball's flight. That's why every great free kick specialist has developed a style of their own. Roberto Carlos became famous for producing explosive curves from impossible angles. David Beckham combined precision with graceful sweeping curl. Juninho Pernambucano could bend the ball in ways that left goalkeepers completely helpless. Lionel Messi often creates beautiful controlled curves with remarkable consistency. Different techniques, different styles, but the same invisible laws of physics. The science never changes, only the way each player uses it. The greatest players don't break the laws of nature. They understand them, and then they make those laws work for them. By now, you might be thinking, every spectacular free kick works exactly the same way. Not quite. There is one famous exception: Cristiano Ronaldo. Some of his most memorable free kicks follow a completely different path. Instead of producing heavy spin, he often strikes the ball almost through its center. The ball rotates very little. Sometimes it barely spins at all. Yet it still behaves unpredictably. It swerves, it wobbles, it changes direction. Sometimes more than once. Goalkeepers find it almost impossible to predict, because unlike a spinning ball, this one isn't following a smooth, graceful curve. The air flowing around the ball becomes unstable. Tiny swirling pockets of air appear, disappear, and reappear. Each one gives the ball a tiny push. First one way, then another. The result is a flight that seems completely unpredictable. Football fans call it the knuckleball. Different technique, different physics, but the same lesson. The greatest footballers don't simply kick the ball. They understand how to make the air work in different ways. Nearly 30 years have passed since that unforgettable free kick in France. Yet football fans still watch it, again and again. Not because it broke the laws of physics, but because it revealed just how beautiful those laws can be. What looked like magic was really science. What looked impossible was really nature, working exactly as it should. Every unforgettable free kick is a conversation between the player, the ball, and the invisible air surrounding it. The greatest footballers don't possess magical powers. They possess something even more remarkable: years of practice, thousands of hours of experience, and an extraordinary understanding of how to make nature work in their favor. The next time you watch a football curl around a defensive wall or dip perfectly beneath the crossbar, remember this: the ball isn't defying the laws of physics. It's obeying them perfectly. And perhaps that's the most remarkable part of all. Because the more we understand our universe, the more extraordinary it becomes. I'm Dr. Alex. Thank you very much for watching Science Unlocked. If you enjoyed today's episode, please like this video, subscribe to the channel, and share it with someone who loves football, or simply loves discovering how our world really works. Until next time, keep asking questions. and keep unlocking science.